Hello YouTube, this is Jay and welcome to your 7th tutorial. This tutorial is going to be on the I2C bus, and the I2C bus is similar to the serial bus that we learned about in the last two tutorials, except it has some advantages over just using the simple serial protocol. First being that it can support multiple devices on the same two wires, and you don't have to worry about the speed setting, so the speed does not have to be defined in the code like with serial. And lots of different sensors support I2C. Accelerometers, gyros, light sensors. There are literally hundreds of sensors that support I2C. So it's definitely a really good protocol to learn if you're trying to connect a sensor to your Arduino. I'm going to start by talking about what you're looking at on the webcam. I removed the LED and the button and the potentiometer, and I've added these two blocks, and these two blocks represent the Pro Nano, which you can get on my website. The Pro Nano uses an ATtiny85, and they are pre-programmed with the DigiStump bootloader, so you can program them using Arduino. And the two that I have on the breadboard have already been programmed, and I'll show you the code that's on them a little later. The SDA pins are tied together, and the SCL pins are tied together, and then they are powered up with 5 volts. Those two pins are connected to the Arduino Uno pin A4 and A5, which are the I2C bus, and those two pins are also pulled up to 5 volts using a 4.7K resistor. Now the I2C protocol uses an open drain output, and what that means is these two pins can only be a low or a high impedance. They cannot be a high, and so you need these two resistors to pull that up high. And the reason that is so that these two slaves can acknowledge the packet that's being sent to them by holding the line low, versus letting the line, and if this wasn't here, nothing would hold the line low, and then the processor would know, hey, there's nothing there, or no one's responding to me. So these two have been programmed already, and I'll show you the code, and they have been programmed with the address 8 and the address 9. So when I send a packet to them, I can address the packet to 8 or 9, and they will respond accordingly. They also have built-in LEDs, so I'm going to use the green LED that's built in instead of adding my own external LED. Okay, let me show you the protocol. This is the protocol that I got on Wikipedia, and I just isolated this so that it's really easy to explain. And there are 5 main points about I2C. First, it uses 2 wires that I just showed you, SDA, serial data, and SCL, serial clock. The data is started when the SDA is being pulled low while the SCL stays high. So when the SDA pulls low and SCL stays high, that signals a start bit. The SDA sets the first data level while keeping SCL low during the blue frame. So right here is the first bit being set, and then the data is sampled when the SCL rises, which is the green for the first bit right here, and then it repeats over and over and over again until it reaches the last bit. And then a stop bit P is signaled when SDA is pulled high while SCL is high. So right here, when it's pulled high while this is high, that signals the stop bit. So this is the packet that's used to transmit data as well as the address, and I'll show you that in a logic or a signal capture instead of trying to explain it here. But this is basically how I2C works. I'm going to go ahead and close that and write some code. So let's open a blank sketch. And so what we're going to do is we're going to start by including a I2C library. This is the first time I'm using libraries, so the way you include libraries is just by using the word include. And the name of the library is called wire. So that is the I2C library in Arduino. Next, in setup, we want to write wire.begin, just like we did with serial. And we're ready to start writing some code. So the two controllers are waiting for the letter H or anything else. So I'm going to go ahead and send it an H, and that'll allow me to turn the LED on. So wire dot begin transmission. Close. And then inside of here you want to put the address that you want to send the data to, so 8. So that'll send the first packet, and it'll let the device 8 know that the next byte is for it. So write, and then do an H, and then we'll do write, wire dot, actually we'll do end transmission, and we're only sending it 1 byte, but you can send multiple bytes inside of between the begin and the end. I'm going to go ahead and copy that, and we'll send another packet, but this time we'll send it to the address 9, and we won't send an H, we'll send that an L for low so that it keeps that LED off. And then add a delay for 500 so we can see it, and then just repeat that. This time we want to switch which one's high and which one's low, so I'll do L and H. And that's it. That's our code for driving those 2 LEDs on the breadboard. Now let me show you the slave code. Here's the slave code. And this is using another library called TinyWireS, which is just it's the same library but written for the Tiny processor. And the setup code, I have the LED as an output and I have it off, and I am beginning it with an address 8, so this will respond whenever the master, so this is the master, this is the slave, whenever the master sends it a 8, this device will respond. And then on receive, it's going to jump to this function and process the data that it received. And in the loop, it's just, you have to call the TinyWireS stop check so that it can process the data. In the receive event function, we're going to wait for the data to come in, and once it's there, we're going to save it to variable C, and if C is H, we'll turn the LED on, and if it's anything else, we'll turn it low, so off. And that's it. So I've programmed this already on the Tinys with an 8 and a 9, and I'm going to go ahead and program the Uno now, and what we should see is the LEDs bouncing back and forth between 8 and 9. So let's go ahead and give that a shot. All right, and there you go. So you can see the LED is bouncing back and forth as expected. And I'm going to go ahead and open the logic analyzer. And this time I have 2 wires connected. I'm going to hit the analyzer. I'll add an I2C analyzer with data on channel 0 and clock on channel 1, and I'll hit save, and then we'll go ahead and sample for 1 second. Okay, and here you can see we've got some packets, so we'll zoom out and find them, and here's the first packet. Okay, and what you're seeing is the bottom one is the clock, so it's basically just going up and down, and every time it goes up, that's when that data is valid. And then the top one is the data itself, and you can see that this part here writes an address which is not 8, and this part here writes an address that's not 9, and here's the low and here's the high. You can see the H and the L. You can also see the acknowledgements, which is the last bit of each of these packets. And the reason you're not seeing 8 and 9 and you're seeing 16 and 18 is because the library adds an extra bit to let it know that it's writing to it or reading from it. So if you just remove that extra bit, you'll get your 8 or your 9. And that's it, and that repeats itself over and over again, and that is how I2C works. So I hope you give that a shot. Download the code and play around with it and see what you think. Thank you for watching.